Alright, what's up, Algebra 2? Let's work through the first 9 weeks review for the exam. It's going to be like the last review. I'm not going to work through every problem. I'm just going to hit the ones that I feel need emphasis. So let's look at number 1. Given the graph, find the domain range and where it's increasing, decreasing. All right, so domain, it's the x values. X goes from, it starts at -4, and the arrow implies that it continues towards infinity. It's a closed circle, so the domain, it's going to go from -4 all the way to infinity, and infinity always gets the parentheses. The range is going to go, it's the y values. So the range is going to start from, we'll call this also -4. It goes up to 5. However, because of the arrow, it implies that it basically goes on forever towards infinity, right? So this is actually going down, right? Because we're talking about the y values, the range. It's going towards negative infinity. So this range is going to be from negative infinity up to and including 5. So we'll use a bracket. Where h of x is decreasing, this is going to be all in terms of x. So basically think of increasing and decreasing as uphill and downhill. All right, so let's look at decreasing. So we always go from left to right, and it's always in terms of x, from left to right. The furthest left is going to be at x equals -4. And it's decreasing, so we're going downhill from -4 to x equals -1. From -1 to 2, it's uphill. So we'll call this increasing. And then from 2 to infinity, from 2 to infinity will be decreasing as well. So there's 2 sections that are decreasing and 1 section that's increasing. So we're decreasing on the interval, and it's always parentheses for increasing and decreasing. It's decreasing from -4 to -1. Right, x equals -4 to through x equals -1. Union from 2 to infinity. The function's increasing from -1 to 2. Right, it's the part that's in the middle. All right, for negative, it's going to be the part that is below the x-axis. So below the x-axis will be from x equals 4, well, parentheses not including 4, up -4, up to about 0.5. Right, we're not going to include -4 because at -4, it's on the x-axis, so that would be 0, and 0 is not negative nor positive. So that's why we're using a parentheses. For positive values of the function, we're looking at above the x-axis, right, above the x-axis. So above the x-axis will be 0.5 all the way to, all right, so here we have to kind of interpret what's happening. right? Because this goes on towards infinity, it actually goes below the x-axis. So if we continue this line out, we can call it 1, 2, 3, 4, 5. Call it 6, right? From 0.5 to 6. The function's positive, meaning it's above the x-axis. And from 6 and beyond, right, 6 and below, it's the other section that is negative, right? Because it dips below. So 6 to, in terms of x, we're going towards infinity. All right, number 2. We're going to write -3 is less than or equal to x, which is less than 1, in interval notation. So this means -3 to 1, right? We're not including 1, so it's a parentheses. However, we're including -3, so it gets the bracket. So on the graph, really you could choose any numbers you want or any lines that we want. So if we call this -3, so it'd be -2, -1, 0, 1. And that'll be an open circle. And it's everything in between. All right, number 3, we're given an interval and we want inequality. So this is saying from negative infinity all the way up to and including 2. So this is going to look like, so 2, and x is going to be everything smaller than 2. Right, so you could write this, x is less than or equal to 2 because it's including it. So graphically, if we call this closed circle, right, because it's including 2, and it's everything below less than, number 4. We have 2 sections here, the or, right? So there's going to definitely be a union. So we're saying x is less than -4, or x is greater than or equal to 0. So if we call this -4, right, open circle because it's strictly less than, and we want everything smaller or less than -4, and then 0 or bigger. So -3, -2, -1, 0. So we're including 0, and we want everything bigger than 0. All right, number 11. We have a set that has points. 5, 9, 5, 8, 5, 7, 5, 6, 5, 4. And is the relation of function justify your answer? Okay, this would be no. Definitely not. It's like, well, why? Because the x values, x repeats. All right, for it to be a function, x cannot repeat. You have one x value with a specific y value. You can't have one x value with multiple y values. It doesn't work that way. So this is a no. Number 12, is this a function? Well, every x has a specific y value, and we call it the vertical line test. We draw a vertical line, and as long as the graph touches it once and only once, then it is a function. So we'll call this one yes, it is a function. And the reason it passes the vertical line test. Vertical line test, VLT. All right, number 13. Fill in the blank for each parent function graph. All right, so the equation for 13, this is going to be, it's a quadratic, right? It's x squared the name is quadratic. The domain, so for a quadratic, the domain is always all real numbers. And the range is going to be from the min or max towards one of the infinities. Right? If it's the min, it's going to go towards positive infinity. If it's the max, it's going to go towards negative infinity. So this one has a min, and it goes towards positive infinity. So the range is going to be from 0 inclusive to infinity. So bracket around 0 because we're including 0, and parentheses around infinity because infinity always gets the parentheses. All right, number 16. This is going to be the absolute value of x. The name of it is the absolute value. The domain, again, x values, all real numbers, right? Negative infinity to infinity. And the range is going to be from 0 up towards infinity. So 0 to infinity. 0 gets a bracket because it's a closed circle, and infinity always gets the parentheses, no matter what. Number 17. This is a y equals x, which is a linear function. It's a straight line. The domain here is all real numbers, right? Because the x value goes towards negative infinity and positive infinity. The range, again, all real numbers, right? Because no matter what y we pick, it has a specific y value. Number 18. This is going to be x cubed, or a cubic function. The domain for this, again, all real numbers. Range, you guessed it, all real numbers. All right, let's look at number 27. Sketch the graph of y equals 2 times the absolute value of x plus 3 minus 9. Show at least 5 points and give the coordinates of the vertex. All right. The vertex, right, is at HK. So whatever's inside the absolute value next to x, that's basically the x value of the vertex. And whatever's outside this k value, it's the y value of the vertex. So inside always lies. So negative 3, right? Because it's x plus 3. So negative 3. And the outside, we take it as is, right? Negative 9 or minus 9 will be negative 9. So the vertex is going to be negative 3, negative 9. So here's negative 3, negative 9. Okay, some characteristics of the absolute value function. We have the axis of symmetry, very similar to a quadratic. When x is 0, right, when x is 0, because now we're picking points. So when x is 0, I want what? So y is equal to 2, absolute value 0 plus 3 minus 9. So this is going to be 0 plus 3, which is 3, minus 9. Absolute value of 3. So the absolute value takes whatever value that's inside of the bars and makes it positive. So 2 times positive 3 is going to be 6 minus 9. And that's going to be negative 3. So when x is 0, y is negative 3. We can reflect that across the axis of symmetry. let's pick -2. When x is -2, what happens? All right, when x is -2, we're going to get two times -2 plus 3, absolute value, minus 9. So -2 plus 3 is 1. So that means 2 times the absolute value of 1 minus 9. So 2 times 1 is basically 2. 2 minus 9 is going to be -7. So when x is -2, y is -7. So -2, -7. And we can reflect that across. So here are our 5 points. Connect the dots. Keep the arrows going so it goes in both directions up. Number 28. Solve. Absolute value of 3g plus 14 equals 7. All right, so absolute value, when it's equal to something, we can write two versions of it. There's the positive version and the negative version. So 3g plus 14 equals 7. 3g plus 14 equals -7. All right, we just solve for g in both instances. Minus 14. 3g is equal to -7. Divide both sides by 3. So one case, g is equal to -7/3. In the other case, -14, -14. 3g is equal to -21. Divide both sides by 3. G is equal to -7. So the two answers, we'll box them. G is equal to -7/3. And G is equal to -7. All right, number 29. Solve. The absolute value of 5x minus 4 is equal to -6. All right, so this problem, remember what absolute value bars do. Right, absolute value takes whatever's inside and returns a positive value, no matter what, right? No matter what I plug in inside the absolute value, a positive number must come out. So here we have the absolute value is equal to -6. This is not possible, right? Like there's no solution to this. And that's because absolute values must return a positive number. So if absolute value equals a negative number, immediately there's no solution. Immediately. All right, number 30. Sketch the graph of 3x minus y greater than or equal to 1. So here, if we solve for y, okay, so -y, so I'm going to divide both sides by -1. Or multiply both sides by -1, however you want to look at it. So this is going to be y greater than, actually, it's going to flip. So we're going to get y is less than or equal, because it flips, 3x minus 1. Okay. -1. That's the y-intercept. We're going to go up 3 over 1. Up 3 over 1. All right, it's less than or equal, so it's a solid line. And do we shade above or below? That's the question. So I like to pick 0, 0, plug it in, and then see what happens. Right, so is 0 less than or equal to -1? No, it's not. 0 is bigger than -1. So it's a false statement. So that means I have to shade on the opposite side of the line of the point that I picked. All right, so I pick a point on one side of the line or the other. So the point's on one side. You plug it into the function. If it's true, you shade on the same side that the point is on. If it's false, you shade on the opposite side